Greetings. We're here to talk about how AI will impact energy risk engineering. So you clicked on it. Let's jump into it. Right. All right. First, we're going to talk about use cases because everybody likes to know what they can do with AI, and it's really helpful to have some examples of what can be done. We'll talk about the power required because it's going to require a lot of power plants to be built, and that's going to impact energy risk engineering. And we'll talk about Deepseek and other models like it, and I'll explain to you why it made such a ruckus, and we'll talk about what its impact in the big picture will be. And then we'll talk about data center risk because we may have combined projects where we have data centers being built. They're massive users of power, and so the power plants that go along with them, we may find ourselves being involved with risk assessments of both the power plant and the data center. All right, I made the statement a long time ago that one day we will all have email addresses, and we do. That was back in the early 90s to the Edison Electric Institute Loss Control Task Force. So, what are some of the AI platforms that we can use? You've probably heard of ChatGPT. You may have heard of Claude. DeepSeek, you've probably heard of. Quen is awesome. Perplexity, very good. Notebook LM, different, but also very good. And then Grok 3. It's amazing. One of the best things about Grok is it's maximally truth seeking. All right, before we get too far into the presentation, I want to remind you about AI data safety. Some models learn and some don't. You want to be careful about using confidential data. Use it only in internal models or anonymize it if you're not. Don't upload anything that you wouldn't post on social media. If it's an internal system, you're fine, but otherwise be very careful with it. Now let's get into these case studies. Video risk engineering reports. These are pretty wild. This is where you can turn regular risk engineering reports, written documents, into videos that are much easier to watch and digest. Imagine being able to watch a 10-minute video that takes you through a 30-page chemical engineering report for a refinery or chemical manufacturer. Engineering report briefing. Say you don't want to read the whole thing or you want to have it quickly at your fingertips during a meeting. You can convert these documents, 30-page documents, any length document, down into 1 or 2 pages so you get the gist of what's in the report. And it's very handy when you're going to be in a meeting and have several of these to go through to remind you what this facility was all about. Codes and standards briefings. You'll hear about briefings a lot. Briefings are something that AI is really good at, taking long documents, making them brief, and giving you just the information that you need out of them. But codes and standards briefings can do that for the ability to understand a code or a standard without reading the whole document. Photo equipment explanations. I'll show you some examples there where we actually take pictures of equipment out in the field and ask it to explain what are we looking at. And then we'll look at photo hydraulic analysis. We'll be able to take pictures of the hydraulic placards on fire sprinkler systems, compare that to pictures of the warehouse storage, and ask, will this equipment be protected by that hydraulic system, by that fire protection system? Shop invoice versus the policy. I took a repair invoice from a gas turbine wreck and an insurance policy, put them both into AI, and I said, find the covered damage. It not only found the covered damage, it pointed to me in the policy where the coverage was. It found the non-covered damage, pointed out the exclusion. So as an insurance agent licensed, I was able to make sure it wasn't garbage in, garbage out, but it sped up my work tremendously. Let's look at a video engineering report right now just to give you an idea of what they're like. The Specialty Partners Refinery in Shreveport, Louisiana was the subject of a property insurance loss control survey conducted by Star Technical Services on October 18th, 19th, 2022. The survey included discussions with plant maintenance and operations managers, as well as the inspection supervisor, safety specialist, and VP of tax. During the visit, various aspects of the refinery's operations, maintenance, and facility layout were reviewed, including process control, building construction, maintenance practices, and mechanical integrity. As a result of the survey, 4 new recommendations were made for loss control and risk improvement. One of the previous recommendations remains open. 5 recommendations have been completed, including the extension of the sprinkler system, inspection of the deep well pumps, plugging of inspection ports, securing the old control room, and development of an emergency isolation valve placement document. The new recommendations include the inspection of vibrating piping, installation of fixed LED detection, correct low positive purges on junction boxes, and train for operators in the use of fire monitors. The facility personnel were well prepared for the visit, and management demonstrated its genuine commitment to the property loss control process. Partners is a leading producer of specialty hydrocarbon products with facilities in Indiana, Louisiana, Missouri, Montana, Texas, and Pennsylvania. The company is divided into two segments, specialty products and fuel products. Shreveport Refinery is part of both segments, producing both fuels and various oils. The refinery has a capacity of approximately 57,000 barrels per day and typically processes between 42,000 and 55,000 barrels per day. It is a moderately complex facility with hydrotreating, catalytic reforming, deasphalting, and lubricant base oil processing units. At the time of the survey, the facility was operating at 49,230 barrels a day. Okay, so that's what one of them looks like. And now we'll talk about photo equipment explanations. What I did was I was out at a solar farm, took this picture and said, explain this photo was really all I asked it to do. And it gave me an awesome explanation. It told me that it depicted an outdoor setup likely related to a solar energy installation. That's true. Told me that the cabinets were probably full of inverters. And that's how we convert the DC power from the panels to the AC power for the grid. Might also contain switchgear, transformers, monitoring systems. I kind of knew that stuff, but it went deeper. I kept, well, I didn't ask it anymore, but it kept explaining the security and monitoring. It saw a pole there with cameras on it, and I didn't really pay attention to that. I wasn't looking at the security, but it pointed it out. And it pointed out that there was a person there in the side of the photo that was taking pictures, probably for documents and maintenance. And then even further, it went through and it said that look at the dry grass around the area. It indicates a need for proper vegetation management to prevent fire risks. That's true. If you look at the vegetation is actually encroaching up on that pad. So it's amazing what the AI will see that we don't necessarily see in the first place. Photohydraulic analysis versus the hazard. Here we go. So these are the hydraulic placards. A StarTech engineer was in the facility. He had a concern about the protection, took a picture of these hydraulic nameplates. That's not him. This is AI, an interpretation of what AI thinks an engineer, fire protection engineer looks like. But we had stacked IBCs that were full of oil, and they were 3 high. And this StarTech engineer wanted to send that photo and the hydraulic nameplate photo back to his home office so their corporate engineer could look at it. Well, that evening, I just asked AI to look at it. And what did we get? Well, I asked this question: would IBC containers full of oil stacked 3 high be protected by these systems? AI said pretty much no. It's going to be a very severe fire. It might be able to contain a small fire, but not one with the storage arrangement that it's looking at. And it gave me the reasons why. It told us that the listed flow rates weren't adequate. So it gave recommendations. I just asked it, will it work? And it said no, but then it went through and gave us recommendations. Increase the density. Of course, that needs to be done. We thought about that. Consider in-rack sprinklers. Use a foam water system. Now, this is one we didn't immediately think of, but it made a lot of sense when we started thinking about all the extra water we were going to be pouring into this warehouse. Evaluate the water supply. So it gave us very thorough recommendations to make sure that this system could handle that hazard. More use cases. Let's keep going. AI-generated risk engineering reports. Now, this isn't just a video report. This is taking all of the raw documentation that, as risk engineers, we ask for before we go to a facility, such as maintenance records, outage reports, the last time the fire pumps were tested, their annual reports, battery testing. All of the information that we request, you can put it into AI and ask AI to write a risk engineering report. It's pretty phenomenal. AI-generated standard operating procedures. This is a great way to get a quick procedure written that covers what you're looking for. I had a facility out in California that was a small hydro facility, very small, and they needed a hot work procedure. It was something the insurance company recommended. They asked us, where do we get started? There's many of them out there that you could cut and pasted from, but I just asked AI to write a new one for a small hydro facility in California, so it was tailored for the project I had. I wouldn't have had the resources or time to start one from scratch, but the head start that this gave me made it very worth doing for a small client. Risk recommendation themes across fleets. Now imagine you've got 20 locations around the country, landfill to methane capture facilities, and you have over 100 recommendations, and you need to go through them every month with the insured. Well, let's ask AI to take all 100 of those and give us a common theme across any of the facilities if it could find them. Well, lo and behold, we did that, and it found 10 common themes across 20 locations that if you go out and approach those, you talk to risk management and to corporate vice presidents of engineering, hey, guess what? If you do these 10 recommendations, it's going to apply across your whole fleet. So it's something that helps you target the low-hanging fruit. PSM light procedures. If you have a recommendation to perform or to write a management of change procedure for a facility that's not in PSM, but yet you want to approach it, professionally, you can ask AI to write you that procedure tailored for the facility that you have, so that it gives you a PSM light version, but you're not going to have to jump through all the hoops for a full PSM facility. Fast one-off procedure development. Again, if you have to develop something for a small facility, it's easy to do it quickly. Special hazard protection guidelines. We'll get to more about this, but say that someone's going to do something at their plant and they want to know what they need to do to protect it. Here's what we had happen. We had a storage situation for a spare generator step-up transformer. They were going to buy the spare and they were going to store it in a building. They wanted to know how to build the building. Well, AI, they asked us to find out what the insurance company was going to require. We sent that request off and then asked AI at the same time. We got the AI request much quicker than the insurance company response. And basically, the first thing they started with was temperature control and environmental, because that's what's going to destroy your spare parts and equipment is humidity and temperature. So, and they even wanted redundant equipment in there too. Humidity management. Humidity is going to cause your biggest problems. Physical protection. It asks for fire protection, all kinds of fire protection, early warning, firewalls, spacing, FM200 system. So when the insurance company replied back, they said to at least put sprinklers in there, some sort of fire protection system. So at least the insurance company wasn't completely off of what AI was asking for. Now let's get into more use cases. Training programs based on standards and videos. We can take a standard PDF document. We can take a video from YouTube or a training video. We can freshen it with AI. New equipment proposals versus codes and standards. This is a great one. Suppose someone wants to store lithium-ion batteries in a flammable liquids cabinet that they want to buy. Will it work? Is the flammable liquid storage cabinet going to be adequate to protect lithium-ion batteries in storage? You can ask AI to compare what you're trying to do with what the codes and standards require. Root cause analysis briefings, RCA briefings. We can take these root cause analysis that are very long, detailed, and we can shrink them down to 1 or 2 pages so we get just the gist of what's going on. Very helpful when you're just trying to find out is something covered or not, is something going to be covered or not. Dissolved gas analysis interpretations. We'll get into those. We got the red arrow. Annual fire pump performance interpretation. This is when, you get the results. This contractor said everything's okay, and you just want to know, is it really okay or not? Because believe me or not, over the years, I've seen so many that are checked okay, and the performance is way below manufacturer specs. Annual podcasts and documents of videos. If you take a document or a YouTube video, you can convert that into an audio-only podcast. It's very easy to listen to on Spotify or Apple Podcasts. I have two channels that I do that with energy risk stuff. So check my social media. You'll find that, and I'll put them in the links. But I'll give you Spotify and Apple Podcasts to many energy risk engineering topics. Report graphic generation. If you've got a report that's just full of all text and text and words, and you need to spice it up a little bit, Napkin AI is great for converting your text into graphics. Drafting proposals. If you're ready to do some work and you need to propose the work, write statements of work, then AI is great for drafting those. Now, all I asked it to do on this dissolved gas analysis report was interpret this report for risk engineering and insurance purposes. It gave us a great asset overview of what the transformer was, what kind of oil was in it, where it was, how many gallons, its operational status. Then it looked into the markers. It looked into the actual gases, and it found that in a couple of gases we were exceeding normal limits. It told us what might be causing those limits to be exceeded, thermal and elevated temperature, electrical fault. But even beyond that, it told us that there's no active escalation of fault conditions. So it looked at the history, which is really good, because a lot of people just jump to the latest and they look at the gas and they say, okay, we've got a problem. You may not have a problem. You need to look at the history, and that's what AI did just from that simple prompt. More use cases. Let's keep going. So I strategized around at a new golf course. Yeah, just mixing a little bit of work and pleasure. Writing articles. I write a lot of articles for LinkedIn, and AI gets me started. It's really helpful for thinking through articles. Philosophical discussions. What is worthless and priceless at the same time? AI came up with a lot of answers. My particular reason for asking the question was I thought about Bryson DeChambeau's clubs. They're all one length, so nobody else can really use them. And yet they were used to win the U.S. Open, so they belong in a museum. So priceless and worthless at the same time. Process flow diagram explanations and process improvements. We'll get into that. Production data interpretation. I was sitting in a presentation, a bunch of engineers around the room, some financial slides come up. I wanted to understand the finances better of this facility, so I took a picture of it and asked for an interpretation from AI. Quickly, I knew what the most important product line was, so we'd know what equipment was the bottleneck. Regardless of how it was configured, now we knew what the reason for the facility was and what the online or the market price was at the current time. So I actually knew more than the vice president of finance knew sitting next to me. I definitely knew more than the rest of the engineers in the room. So here's the engineer getting ready to take a picture of a process flow diagram. That's the one that I took the picture of. It's very detailed. Here's the explanation. It's a refinery. Talked about the different processes: distillation, hydrotreating, catalytic reforming, de-asphalting. So it was great at explaining the process to me. So I told the manager of engineering from corporate, take a look at this. Look at what it got from just looking at that picture of that process flow diagram. He said, can it improve the process off the cuff? So I said, let me ask it. So it did. And it actually came up with ways to make the process better. Many of them, a dozen, ways to improve the process. One was just to upgrade the heaters to have more efficient heaters. Let's get into even more use cases. Developing maximum foreseeable loss and probable maximum loss in facilities. If you give enough information, AI will tell you what's the worst that can happen and how much it'll cost. It's really amazing. You can learn anything, and there's different ways to do it. You can just ask AI to explain it, or with Notebook LM, you can go into a particular document and start interacting specifically with that document to learn from it. And you can understand the reasoning behind it. A question came up as I was preparing for this presentation about how do we guarantee no garbage in, no garbage out? Well, you have to understand reasoning. And if you see how the AI reasons, you'll have a better sense that it came up with the right answers. Stock suggestions, AI data center cooling companies. If you've ever thought about picks and shovels of the gold industry, what is it for data centers? It's the cooling companies. Interpreting health test results. My last physical, the doctor said, hey, John, do you mind if we record this with AI. At the end, it'll have all the notes. I won't have to spend time taking them. I'll be able to just interact with you better. I said, that's perfect. I understand AI. Go ahead and use it. But I wanted to interpret the results of my tests with AI. And AI is great for helping you understand supplements and nutrition, which doctors don't. They don't understand that. They don't get trained in it. So you can use AI to interpret your health and get better suggestions. Gravel versus mowing at solar facilities. We'll talk about that because I had a concern that you might actually save money if you could put in gravel instead of having to mow and maintain vegetation clearance around the panels. Got an interesting story about that. And then the golf ball spin analysis. This really applies to flywheel energy storage systems. My example will be about a golf ball spinning, but it's the eccentricities that are interesting to flywheel energy storage systems. So with a solar plant, what do? We have one option, that's to clear the vegetation, replace it with gravel. The second option is to mow it and cut the vegetation and keep paying that annual cost. So here's the option one's got, a gravel maintenance cost of $25,000 annually. And the mowing is going to have its own maintenance costs. So what are we going to do? Well, if we add the fire frequency, now this is something that came about because I realized that the facilities out in California have way many fires than the facilities in the Northeast. So we had to distinguish and what was going to be if we're going to try and prevent a fire, and the gravel is going to be very good at that versus mowing, because a lot of times mowing gets skipped or neglected and, you could have more fire. So it turns out that in this example, a fire frequency of basically 1 in 3 years was going to be enough to justify installing gravel. But it wouldn't quite do it just yet. I went out to the facilities and talked to the operators, and their concern was that if we install the gravel and later they can't spray the weeds, that they're going to have to still weed whack. And if they have to do that around gravel, they have to worry about shooting the rocks up into the modules. So they're very nervous about gravel getting too close to the modules. Gravel's great for the roads in between. It does act as a fire break. I've seen it firsthand. So it's got its places, but be careful about just wholesale graveling an entire solar site. Let's get into more use cases. That's what everybody loves. All right, golf ball spin analysis. Let's do it. So this is how we make sure we don't have garbage in, garbage out. We have to understand the reasoning. That's how we make sure we don't have garbage in, garbage out. And research is part of that too. So with research, it goes out onto the web and it gets information. You remember the early days of ChatGPT, where it would warn you that my training is only good up to 3 years ago. So anything that's happened since then, I don't know about. Well, that turned a lot of people off of using AI, and not to mention the hallucination part of AI, where it would just make up answers. Well, with research, you get the latest information. With reasoning, you get to see how it comes up with its answers so that you know that it's not just hallucinating. So I gave it a very long prompt. I said, I play golf. I like to strike my balls with a check-go spinner that spins the balls at 10,000 RPM. Speed causes the balls to shift to a repeatable position based on the internal weight distribution. This is where the flywheel energy storage system comes in. If you have eccentricity in an object that's spinning, you're going to find that it tries to change its location. So I was concerned that as it did that, as the ball flew through the air, that the conservation of angular momentum would cause the ball to curve. So I asked AI to help me with this problem. Take a look at what it looks like. Right? It comes back every time. So like 99% of the time that I've done this, and I've spun many balls, 10 dozen balls in the last few years, and all but 2 or 3 came back to that same line. Why did those 2 or 3 not come back to it? They were perfectly balanced. That's very few, even though the manufacturers say that they all are. So I went through the analysis, and you can see AI talking to itself, and it says, first, I need to understand how the weight distribution inside the ball affects its flight. I should consider the relationship. Then I should look into this eccentricity. So if you read how it's reasoning, you can decide whether it's making sense or not. And you'll find it catching itself going down the wrong path. You'll find itself rewarding its understanding and its guesses and getting better. This is what's neat about the new AI models that weren't available with the original ChatGPT, that was just trained and then spit out responses based on the training, garbage in, garbage out. Maybe I should look into how similar studies. I need to be careful with my assumptions. This is amazing, and this is just a snippet of what it really spit out. It takes a long time to read everything that it used. And in the end, it finally came down and it said that, the alignment process can be useful for consistency and setup, but its impact on the ball flight during play is negligible due to the stabilizing effects of the ball spin. So, okay, it says that, and I stopped striping my balls for a while. But then I noticed that if I hit a ball in the woods and somebody else went over there from another fairway and they saw it and we had an argument over whose ball it was, I didn't have my stripe on it to conclusively prove, hey, that's my ball. So I'm striping my balls again just to make sure I identify them. And I play tournament golf. I have to have my own markings on them, so I'm striping them again. So this is now where we get into the power requirements. How as energy risk engineers, all of those applications of AI get fed and why it needs so much power. All right, one graphical processing unit uses about 1,400 watts of power. Data centers are now using 100,000 to 200,000 of these GPUs. So think in the terms of hundreds of megawatts of power just to run the computers. And then think, if you're making all that heat from the computers, that you have to get rid of it. So the cooling systems are another couple hundred megawatts of cooling capacity that need to be removed. So that's more power to run the cooling capacity. All right, so what are the steps to train AI? Think of it this way. If you take a dictionary and maybe an entire encyclopedia, and let's take it way out there, all of the encyclopedias in the world, and you scan them all into a computer. And then you say, based on everything that you see, what's the likelihood that the word pie follows apple? If I say the word apple, does it come up apple pie, apple crisp, apple computer? What's the most likely next word? So that's how AI sort of works. It's a simplified version of it. And then you want to do iterations. You want to test it and say, okay, this is how I trained it. Let's see if it gets it right. Well, when you switch from training to those iterations, that causes power spikes, as you refine the models. Now, inference is the next step. Once you've built your model, you deployed it, and people start asking their questions, all those use cases, and getting the responses. Part of that is developing the actual answer, and part of it is learning, and part of that is memory storage of, what it's talking about, so that it can talk about it again to you or to other users. So that's basically why and how AI uses power. And where are we going to see it used? I'll show you some facilities, but Grok can consume, a gigawatt is what they're looking at. That's the output of an entire nuclear reactor. So that's just in the development stage. Now, the inference stage, if you think about a single ChatGPT query, it uses 10 times the power of a Google search. Now, think about that. A ChatGPT query is nothing compared to those deep research things that I just used for the golf ball. So the power requirements are going up exponentially. Now, we'll look at Deepseek specifically and how that's going to impact power requirements here in a minute. But where are we using the power? Well, looking at Louisiana, 1,500 megawatts. Austin, 84 megawatts. Plano, Texas, 40 megawatts. Arizona, 1.8 gigawatts. Ohio, 400 megawatts. Silicon Valley, 700 megawatts. This is all over the country. And folks, it's happening all over the world. Tennessee, 100 megawatts, almost a gigawatt in Georgia. All right, so what are the operating challenges of building all of these data centers, adding all this power supply? Well, you have the distribution system, and the infrastructure of the distribution system is impacted. As energy risk engineers, we need to be aware of this. So what's happening? Well, all of that load being turned on and off, and then don't forget they're trying to feed that load with renewable energy device sources such as solar and wind. If you have a partly cloudy day, the solar's going up and down. You've got the load going up and down. The transformer in between is getting whipsawed, right? So the breakers and the reactors and everything that's in between your load and your power supply can be impacted. And the utilities are going to need to start analyzing their faults and tracking them first, analyzing them and figuring out, was it a data center or was it a distributed energy resource? I've got some work going on a side gig to help people with that. Take a look at the end of the presentation for that. All right, AI data centers and Deepseek. This caused a ruckus a little while ago because it's lowered the training costs from 100 million to 5 million, and it's lowered the compute costs to 1/45th of what they used to be. Now, a lot of people are concerned because Deepseek came from China and they're worried about China stealing all of our data. Deepseek is open source. It can be run on a local computer, not connected to the internet. So just that in itself should give you some assurances that you can use Deepseek safely if you use it wisely. If you are using the public servers, just don't put anything in that you wouldn't put on social media. The analysis I did on the golf ball and the eccentricity, that was done with Deepseek. Now let's get into what makes it so much more efficient. Well, if we're trying to guess the probability of the word pi coming after apple instead of Chris coming after apple, we don't need 32 places to calculate our probability to. If we calculate it just to 8 decimal places, we can reduce the calculation power needed. Using all the words at one time rather than apple and then pi, get into an entire sentence, read a whole phrase, and that's what Deepseek does. And you notice that I mentioned that these learn, so he didn't have to be trained on how to analyze a golf ball spinning, but through the process of its own analysis, it taught itself. So it can actually reward itself and revise its thinking mid-process. So these are some of the things that are making Deepseek way more efficient. The big ruckus it caused, even in the power generation world, was that we're not going to need all these power plants. We're not going to need the nuclear power plants to supply all the data centers. But I want you to think about something. The modern cars are way more efficient than the early automobiles, yet their total demand for gasoline is higher due to more people driving and more miles. That's what's going to happen with AI as well. It's going to come out to the masses. No matter how much more efficient it gets, it's just going to be used more and more. So we're going to need more power plants as it goes. All right, now we'll get into AI data center risk engineering. This is important. We're going to have to look at physical infrastructures. We're going to have to look at computational infrastructures and risks, environmental impact. Right now, what we're seeing is there's such a speed to build these facilities that they're even using simple cycle gas turbines, and they're using internal combustion engines just to get their projects up and running. When they have time for the renewable energies to catch up, they will add those. Data security and compliance, again, that's hugely important. Operational risk management, what do you do when you're running the facility? How do you make sure that your protection systems don't destroy your machines, so that you don't have accidental discharges of water spray on them? AI-specific considerations we're going to have to get into, what the AI is doing and what it's thinking. Business continuity is going to be hugely important, and you're going to find that they're going to be very careful about that because it's so important already. They're very good at thinking about business continuity in the data centers. And cost risk management. Eventually, these things are going to have to pay for themselves. And right now, it's really easy and cheap to get on and use a model. But if you want to embed a model in one of your own programs, that's where you start to pay. So you'll start to see these companies very profitable by renting out or leasing out their APIs for the use in software that's distributed, not under the logo of AI. All righty. With that, thank you very much. And if you're interested at all in a side gig that I've got going on, not competing with the company I work for currently, then scan that QR code and we'll catch you on the next one. Thanks very much.